Hello friends, once again welcome back to Triple Tutorial channel. Here we are going to see the construction and working of an electrodynamometer type wattmeter. Okay, let us discuss. Generally, a wattmeter means which is used to measure electrical power. In addition to this, we can measure current and voltage. And wattmeters can be of two types, electrodynamometer type wattmeter and induction type wattmeter. Here we will discuss about the construction and working of dynamometer type wattmeter or electrodynamometer type wattmeter. Generally, these dynamometer type instruments are coming under the category of moving coil instrument. And here we are using electromagnets, not like permanent magnets. Okay. And can be used in both AC and DC measurements. The scales of the meter is uniform. Here you can see an electrodynamometer type wattmeter. We will see the construction in the coming slides. Okay, basically a wattmeter consists of two parts, a fixed coil and a moving coil. These fixed coils are divided into two equal halves, and the series combination of these fixed coils are connected in series with the load so that they will carry the load current. So that fixed coils are again called as current coil or series coils. Next requirement, that is moving coil. Here you can see this black colored portion. This will indicate the moving coil, and the moving coil is connected across the supply. And a spindle is connected along with the moving coil, and a pointer is attached with this. The moments of the pointer is based on the moments of the moving coil. Okay. So when the current flows through the fixed coils, then what will happen? Field will produced or flux will produced on this current coil, and this moving coil is placed in between these current coils. So that what will happen when current flows through its fixed coils, flux will produced by this field coil, and the flux produced by the second field coil will come in series, and they will contact with this moving coil, and the current through the moving coil is based on the supply voltage. Current through the moving coil is directly proportional to the supply voltage. When the current flows through this moving coil, flux will produced in this moving coil. So there will be three fluxes. Two fluxes produced by the fixed coil, and the third flux which is produced by the moving coil. They will come in contact with each other. Due to this, a force will experience on this moving coil, because moving coil is placed in between these two fixed coils. So we can say whenever a current carrying conductor, it will act as a conductor. Current carrying conductor, whenever a current carrying conductor is placed in a magnetic field, it will experience a force according to Lorentz. That is Lorentz force, we can call it as. The pointer will deflect. This is the main working of dynamometer type instrument. Here in this diagram you can see a resistor R which is connected in series with the moving coil to reduce heating effect. Okay, we can control the current through this moving coil by using this series resistor, and thereby we can control or limit current through the circuit, and thereby can limit the heat. So that a resistor is high value resistor is connected in series with this moving coil. Okay, and this fixed coils and this moving coils are air cord to reduce the hysteresis effect. We know that in every meters we need controlling torque. Here the controlling torque used is spring control. Okay, this point is very important. Spring control mechanism is used in dynamometer type wattmeter, and damping is needed to stop the deflection of this pointer. Here we are using air friction damping. Okay, as we have discussed the principle, whenever a current carrying conductor is placed in a magnetic field, it will experience a force. That force is Lorentz force. Okay, this is the principle of working principle of dynamometer type wattmeter. Now let us see what are the major errors found in dynamometer type wattmeter. Errors found in the pressure coil due to inductance. Okay, pressure coil is the another name of moving coil, that is also known as voltage coil. Okay, I remember to discuss these points in the previous slide. Okay, fixed coils are, again we can call it as current coil or series coils, and moving coils can again once again, or the another names of moving coil is pressure coil or voltage coil. Okay, due to the inductance, some errors will occur in the pressure coil. Similarly, these errors are present in fixed coil also. And mutual inductance errors will be present then, eddy current errors, and errors due to the vibration of the moving system, temperature error. We can reduce the temperature error by providing a resistor, high value resistor, and due to errors due to stream magnetic fields. Okay, these are the major errors found in electrodynamometer type instruments. So these are the main things about the electrodynamometer type instruments. Thank you for watching.